So in the previous segment, we saw what different parameters are associated with IV characteristics of a solar cell. So welcome to Decreation's Resources. Now let us talk about these parameters in detail. So the first parameter is the short circuit current, or it is also denoted as ISC. Now, as the name suggests, short circuit current is the current through the solar cell when the voltage across the solar cell is zero. Obviously, if there is a short circuit, if it is connected completely, there is no reason why there should be a non-zero voltage. So, it is due to the generation and collection of light generated carriers. Now, if you consider an ideal solar cell at most moderate resistive loss mechanisms, then the short circuit current will also be called as light generated current. So in fact, these two terms become identical for an ideal solar cell. So in simple terms, it's the largest current which can be drawn from the solar cell. Now the next parameter is open circuit voltage, VOC. This voltage is the maximum voltage available from a solar cell. And obviously, if it is it's called open circuit, that means the circuit is open, that means there is zero current. So this voltage occurs at zero current. Now this open circuit voltage corresponds to the amount of forward bias on the solar cell due to the bias of the solar cell junctions with light generated current. In simple term, if you want to talk about these two, open circuit voltage is when the solar cell is open circuited, that it is not connected to any load, the current is minimum, basically zero, and the voltage is maximum. And if you look at the IV characteristics, the graph, since current is zero and current is on y-axis and voltage is on x-axis, you will see that this point is going to lie on the x-axis. Whereas in case of short circuit current, which we just spoke about, that where the solar cell is short circuited, that means positive and negative leads are connected together and voltage across the cell is minimum, basically zero, but the current flowing out of the cell is maximum. So that current, if you want to see that point, now since voltage is zero and on x-axis we have voltage and on y-axis we have current, you will see that this point will lie on the y-axis in case of IV characteristics. Now there is also something called as maximum power point. As we know, power is product of voltage and current. So the combination of current and voltage for which the power reaches its maximum value, that is called maximum power point. So the corresponding current will be IMP and corresponding voltage will be VMP. So I maximum power, V maximum power, and the point at which the cell is generating maximum electrical power. Now this is very important from the point of view of practical use, and as you can make a guess, if you look at the IV characteristics, it is going to lie at the top right area in the graph because it corresponds to maximum value of V and maximum value of I. So maximum value for the x coordinate as well as y coordinate. So this is the MPP, and now we will look at other two important parameters in the next segment. So when you look at our IV characteristics, you should always look for these parameters because they tell you the main basic nature of that solar cell.